Hello. In this presentation, I'm going to talk about my visit to TeamCNC. They are located in Evansdale, Iowa, which is near Waterloo. In this video, I'm going to be talking about kind of the details on the company, some of the products and services that they provide. I'm going to follow a product through the whole production cycle, and then talk a little bit about how TeamCNC is working to stay relevant in the industry and what kind of people they look for when they're looking to hire someone new. So first off, a little bit about TeamCNC. They were incorporated in 2008 at their current location in Evansdale, Iowa. Right now, they have about 10 employees. They are working on 2 shifts, and most of their business comes from Iowa, the surrounding states, Wisconsin, Illinois, things like that. They do about $1.5 to $2 million in sales annually, and some of their major clients are going to be John Deere, Ross Camp, Viking Pump, some of the bigger players in that Waterloo area. They entirely work as a second tier supplier, which means that they're not actually producing any products themselves to sell to customers, but they are producing parts that are eventually going to go into things like tractors and pumps for other companies. All of those parts are either things that those companies can't do themselves in-house, either because of time constraints or anything else like that. But at the same time, they are not parts that are high enough volume that it makes sense to get them manufactured in any other way than kind of CNCing in a smaller shop. And so TeamCNC is usually dealing with shorter runs of parts, a few hundred to a few thousand at a time. And they're constantly making different things. They're not always making the same thing over and over and over again, although they can do that, as they say on their website. Some of the services that TeamCNC provides, and this is coming from their website mostly, but I also saw these in process at TeamCNC when I visited. They offer numerical controlled sawing. So it's a horizontal bandsaw that you input a number, a quantity, and a length of material, and it can saw that bar stock automatically without someone sitting there doing it manually. They offer CNC turning and CNC milling, and that's going to be a variety between milling or turning castings down to a specific dimension, or milling or turning parts from stock. So we have some examples of parts here that I got from Chris at TeamCNC. You can see most of these are parts that were turned on a lathe. So this one would have done entirely on a lathe. This one would have been done mostly on a lathe. And then you've got these holes around the sides. We got Delrin. It looks like some sort of Delrin here. Done entirely on the lathe. Brass, aluminum, steel. They can machine all of those parts. The majority of parts they're doing are going to be going through the lathe. When I visited with Chris, he talked about how he likes to use the lathes as much as possible because they are simpler machines, simpler to program, and simpler to operate. But of course, something like this would be done entirely on a mill. So the first process that they have is CNC machining. They've got turning and milling operations that they can do. Here you can see a picture that is not actually from their site, but shows a machine that is very similar to what they're using. They have 5 of these older Akuma CNC lathes. Chris mentioned that they are from the 80s and 90s, maybe the early 2000s at the newest, and that they are programmed almost entirely right here at the console using a conversational program called IGF, which is Akuma's proprietary software that they use. I was looking into that a little bit, and it seems like Akuma still provides pretty much that exact same software on new machines that they sell now. All of the machines here look very, very similar, although they're slightly different models. Some of them have bar stock feeders for parts that are made from smaller stock that can be fed through the spindle, and some of them are going to be loaded manually with parts that are cut on that horizontal bandsaw. They also offer CNC milling. They have 3 CNC mills. They have a partner mill, an Akuma mill, and a Bridgeport mill. This is a picture, again, not the exact mill at that site, but of a Bridgeport mill, very similar to the one they're using. All of those have, flood coolant, through spindle coolant, 4th axis capabilities. And again, even though some of these machines do have the ability to use CAM software and plug in the USB drive, TeamCNC is mostly just programming these machines right at the console using the conversational interface right there. So the next thing I want to talk about here is just an example of a product that TeamCNC made. On the day I was there, they were actually halfway through this product. And so you can see right here, the turning had already been done. That had been done the previous day. So this product started off, of course, as a drawing that Chris received from a company that wanted to hire them to make this part. So Chris talked about the different processes he goes through to kind of give a bid, estimating how much material cost, how much tooling cost, how much time cost is going to be involved in this part. They order the parts, they order the tooling. As you can see they order the stock and the tooling. As you can see on this part, they're using a pretty normal standard turning tool with carbide inserts for the outside. They've got drills, a center drill, a twist drill, boring bar to make these inside diameters, and then threading tools to make the inside and outside threads. These are done in 2 stages, of course. The first step being this one here, milling this face, the outside diameter here, the inside and the threads, and then flipping it around to hold it on this surface to machine this outside diameter, inside diameter, and threads. And of course, adding chamfers at the end of those processes. From there, this part went over to the CNC mill. I believe this one was running on the Bridgeport mill. And you can see it's going to be held in 2 separate orientations for 2 different operations. Here they are adding holes to this face. These are drilled and tapped. They're holding this in a pretty standard machinist vise and using a stop block to position that thing consistently each time. At this point, the orientation of that circle doesn't matter. And then once those holes are drilled, it's moved over into this 4th axis chuck, so it can drill these 3 holes. There's one there, one down there, and then one across from it. 3 holes on the outside. In this case, those holes matter how they are oriented in relation to the 2 that have already been drilled. So you can see a pin here that indexes in that hole there and is used to align that part. One of the things I found interesting here was these parts are actually both mounted in the same mill at the same time. One cycle of the mill is drilling these holes, tapping them, chamfering them, and drilling, tapping, I don't actually know if those are tapped, but drilling and chamfering those holes for 2 different parts at the same time. And so that just helps speed up those cycle times and eliminate the amount of dead time on those machines. Which kind of leads into some of the things I talked to Chris about when it comes to staying competitive. That one really goes into this idea of optimizing machine time. If there's a way that they can use a machine twice as much, then making that change to a program is going to be worth their time. That means that they're going to have an operator that can be doing other things while that cycle is running, and just being more productive overall. He also talked about the importance of building relationships with their clients, making sure those clients know the kind of work that they do and know that they are experienced and expert in their field. And then the final thing, and I think this is probably one of the most important things that I learned from visiting TeamCNC, is that inside of their niche, they are doing a very good job at optimizing what they do. They are not machining very complicated parts. If you look back at some of this part that was turned here, there's similar things that we had to do in class with the outside threading, the boring on the inside, turning an outside diameter. They're obviously doing it at a very high level in a production environment. It's a fairly simple part in terms of what they're doing. And because of that, they are spending money on brand new machines, on CAD and CAM software. They're using older machines, and they're utilizing the conversational interface on those machines and doing it very, very well. Chris talked about salesmen from Akuma trying to sell them new mills. He has a lot of Akuma mills and seems to like them a lot. But he talked about how those new Akuma mills, while they can do some really nice things, are very expensive to maintain. When things break, you're sending out parts to be replaced rather than contacting a local company to come in and fix something. And so they have managed to keep their costs down by using older machines and really being expert at the types of parts that they focus on. Finally, some of the things that Chris looks for in people that he is trying to hire. He does the hiring at this plant. One of the things he talked quite a bit about was the difference between an operator and a machinist, and how that kind of the value that they bring to the company for their time. One of the first things we looked at when we got there was one of the Akuma lathes. He stopped the process and kind of showed me the IGF conversational interface and the visual of what that tool was going to be doing in the part. And when we walked away, the operator pushed the go button, pushed the start cycle button, and nothing happened. He didn't know how to get that machine back out of the programming interface into the actual operation interface. And Chris gave me that as an example of, he's a pretty low level operator. He's new. He's just responsible for loading a blank into the machine, pressing start, and then checking the tolerances at the end. When you get to the other end of that, what Chris considered a machinist would be someone like what I saw working at the mill, someone that can diagnose something going wrong, can look at the code and figure out what might be happening, can maybe do a little bit of that programming themselves. And Chris said he's always looking for people that are willing to learn. He's provided resources in their break room for the employees that if they want to go from someone who just knows how to load parts and press start to someone that does know more about how they actually work, he's provided those resources to learn more about that, to learn more about the tooling, to learn more about the materials, and to hopefully advance if they want to try to do that. And so what he said he's really looking for is not so much someone that has a deep knowledge of CNC, but someone who's ready to do a physical job, who is willing to learn, and ideally has the ability to do some basic measurements and checking tolerances and things like that. So in all, one of the biggest things I would say that I learned here is just that idea that even though we hear a lot about CNC being used with CAD and CAM software, and you see all this stuff being done with, fifth axis milling and 3D milling to make these very intricate shapes, there are quite a few uses, and I'd say it's probably the majority, where something fairly simple needs to be made that can be done on an older machine, and it can be done much more efficiently by someone who has that expertise in not only the conversational milling interfaces that they're using, but also understands how machining works. Chris talked about the importance of being able to really dial in feeds and speeds. And so that's not something that comes from learning how to program a computer. That's something that comes from spending a lot of time working at these machines and understanding how they work at a deep level. And I think that's kind of what I took away, is that there's a lot more need for that than there is for the really fancy 3D milling CAM software kind of stuff. So thank you for your time. I hope you learned something from this, and I look forward to seeing your video, Noah. How do I stop you?